Okay, here we are with the tutorial on how to set up the programming to make the inset top for your table. You might be using glass, you might be using tile. This tutorial should work no matter what material you're using. So what you see on the screen right now is VCarve with, and let me look at this in isometric view here. With my setup, well, the one I'm going to be using for this tutorial anyway, and we'll talk about why it might differ in a second. But if you notice, the top is made as a solid, and this groove is representing the rabbet that we're going to make, or the little recess that we're going to use to inset our glass or tile. We're going to end up using a pocketing command, just like we did on coasters, pocketed those out, to pocket this out. And you have to imagine that your frame just doesn't even have this part in here. It won't matter. The tool's going to make some air passes as we do this. So anyway, this is how this was done. Now I'm going to head back to 2D view here. I'll put this in the straight on view. And here's 2D view. Okay, so what you see I've got here is I've got the white part here. This is my job setup, and it has been set up. Now I'm going to head to job setup. This is where you would normally file, new, job setup. And this is where we go down and pick all the things about basically the piece of wood that we're going to be putting in the machine, the job. So I've made mine 18 by 18, and that's this white part here. It won't be exactly that, and it's pretty important right now that you measure closely what yours is within a 16th and put that in accurately. Otherwise, if you're inaccurate, your inset top won't be centered. So just whether you understand why at the moment doesn't matter, but what matters is that the width and the height, the X and the Y, get entered accurately. So double check, triple check before you put those numbers in. Now the thickness, this one doesn't matter as much, but we'll just put it in as 3/4. And then we're going to reference the surface of the material this time, not the machine bed like we did last time for the coasters. Well, no, the coasters we did surface of material also. But anyway, material surface is going to end up being our Z0, so that's important. And then this is important too, and this is a little different this time. We're going to use as our XY datum position or starting position. We're going to use the lower left corner. That's what we did before. But now we're actually going to use this offset command. And what this is going to do for us is, if you look at our job, notice how there's a grid here, X and Y coordinate here, and this is 0, 0. This represents when the machine homes and goes to its fullest extents. This is 0, 0 of those. And this offset that we're using represents the thickness of our, we call it fences that we're using to put our work up against. So those coordinates are right here. You have to put these ones in exactly. And this is currently what our CNC is set up for its offset based on those fence positions. Now, in the future, this can change because we machine these in. So this could change, so it's a good idea just to check with me and make sure they're still good. And I haven't changed them. Hope to tell you if I have. The other one you can do is go to millimeters here for a second. You can see they make a little bit more sense. The Y is set up so it's 78 millimeters up, and the X is set up for 70 millimeters over. And then I machined those in, and that's because the machine works in millimeters. So I used nice whole millimeter numbers, which converted to these weird inch numbers. So you can enter them in inches, but you have to enter those numbers, or you can enter in millimeters, which are these ones here. So, okay, back to this. So I'll assume you've set those up and you're using that offset so that when the machine starts, we're going to home it right here to its extreme reference point, and then based on the offset, it will just proceed all by itself up to this point where our work is going to be placed. All right, now we're going to move on. Don't scale anything here. This is fine. We'll push OK. And this is fine. I'll say no, not right now. Okay, now the next thing I did after I set up my job is I drew these rectangles, and those rectangles represent the inset. So this outer rectangle is going to be the size of my tile or glass plus a little bit, because it would be nice if the glass went in and had a small gap around it so it was easily set in, but not so big a gap that it's kind of ugly. So we have to think about that. So I'm going to show you how to draw these. So I'm just going to delete these two and delete, and I'm going to draw them. So we're just going to draw a rectangle using these create vectors. Draw a rectangle anywhere in the space. And then, so I clicked once and I dragged and I clicked again and it made the rectangle. So now we actually have to put the size in for our rectangle. So my glass ideally is 12 by 12. You have to measure the piece of glass or the tile that you have. And then what we're going to do is take the exact measurement and increase it a little bit so it can fit in there. So that in this case might be increasing by a 1/16. If you increase by a 1/16, that'll give you a 30-second gap on each side. It may be enough, and this is where it gets a little dicey. If you make it too tight, it really is not great because it's hard to put the tile or the glass in. And if the wood expands or shrinks with humidity, you could crack the glass, I guess, or break your frame. So a 1/16 might work. You could also push it a bit. So we'll look at that now. So if it was perfect, it would be down here in the width and the height, exactly 12 by 12 for my piece of glass. So let's just say the glass was cut perfectly. I'm going to add a little bit of a gap. That would be a 1/16, 0.0625. 1/16 of an inch. So I'm going to get a 30-second each side. If I think that that may be just a little tight, I could start increasing it a little bit. So what's a little bit? I don't know. These are thousandths of an inch here, right? This part here. So thousandths of an inch. I could add another couple sheets of paper, so 8 thou more maybe or so. So 5 thou would take me up to 0.063. Let's go 3 thou more, 0.633. And if you have questions, ask me. 3, there we go. So I've made that just a little bit bigger, and I sure hope it works. I don't want it to be too small. That would really be a problem. Okay, then we'll hit apply. And now I've got this rectangle that is representing the space I will need to router out to fit in my glass. And now I'm going to make another rectangle. Just drag and click. And now this new rectangle is going to be an inch smaller. So it's 11 by 11. And push apply. Okay, that's great. So we'll hit close. Now we'll hold shift, or just window, sorry. We'll just window by clicking and holding on the mouse, the whole thing, and select it all. And then head here to the align select objects and put them in the middle. And there you go, that's exactly what I did. So I put these objects in the middle and they're ready to have a toolpath applied. So what I did for my toolpath, I'm going to hit close over here, is I picked the pocket path and I created a pocket path. And now here's the pocket path that I created. You can look at what I got. First I'll select the whole thing and say I'd like to apply the pocket to this. And the depth is going to be the thickness of your glass. Now, you can measure the glass. It's advertised as 5 millimeter. So if I look at my calculator here for a second, 5 millimeter, and if there's 25.4 millimeters in an inch, divided by 25.4 equals about 0.196 inches. That's the exact measurement of the glass. You might want to have it go just a hair deeper. Having the glass proud gives us an edge on the glass that can chip. So if this is 0.197, we could go 4 thou, maybe 6 thou more. So 197 plus 6 thou is, well, it would take us up to 203, 0.203. So we'll try this. 0.203, and you could always double check that. You can measure the glass in inches with your caliper and you'll know if you're close. And so there we are, 0.203. Next, end mills, what we're going to be using, the 1/4 inch end mill, so make sure that's selected. If it's not, hit select and pick it right here, push OK. Then we're going to head down here. We don't need anything really except, well, we don't even need, that's it. We're done. So we'll just head down to calculate And now I can preview all toolpaths, and then you have what I started with here at the beginning where I was showing you. What's going to essentially happen is the bit is going to cut in the air first and then work its way outwards until it reaches that outer rectangle that we made, or square that we made. And that's pretty much it. You're going to then save this pocket to, close this, highlight, check mark, and go save. And then you're going to save it to the professor, and you're going to save it to the USB. Don't forget, this kind of saving saves a machine file, the MMG file, which the machine wants. It doesn't save your project. If you want to save your project, you got to go up here and do a normal vcarve file save. And it will save this project, into your project folder, wherever you're keeping it. Hopefully it's under documents. Hopefully it's under our course name. That's what you've set up. Okay, I think that should do it. And then don't forget, this is super important. You've got a lot of work into your top already. We don't want to mess it up. So before you run this program, I'd like to look over what you've got here in vcarve. And then we definitely want to do a careful air pass at the machine and observe it closely and build confidence that when we actually cut, this thing's going to work. Okay, well, hopefully it does work, and proof's in the pudding. We'll see it shortly, I'm sure.